Today, lesson 20B, day number 3 of the basics of exponents. On the first day, we reviewed those very basic ideas that you may have learned in 6th and 7th grade. Then yesterday, we talked about what we do in terms of multiplying things with exponents, and then we dealt with power to a power and then also power of a quotient. Today, we extend those ideas out to dividing things with exponents. So let's just go ahead and get started. This example says to rewrite the following as an equivalent expression in simplest exponential form when we have 5 to the 6th over 5 to the 4th. Well, we're going to attack this the same way we've attacked everything, and that's by writing it out as extended products. So we have 5 to the 6th on top, which of course as an extended product looks like that, and 5 to the 4th on the bottom, which of course as an extended product looks like that. And then if we just think about how we normally deal with fractions, when we're normally dealing with fractions, we're trying to reduce. And so we have some 5s that we can simplify. So, 5 goes into 5 once and once. 5 goes into once. 5 goes into 5 once and once again. And again. And we are replacing them with 1, and that will be the most common mistake, because what happens over time as you get better at math, you start finding faster ways and you start cutting steps. Just remember, when you are doing the division like that, you are replacing the 5s with 1 because 5 goes into 5 one time. And so we can see that we have 4 1s that we're multiplying together with 2 5s on top and a bunch of 1s on the bottom. So it should be fairly clear to you that that simplifies to, if we were to leave it in simplest exponential form, 5 to the 2nd power. If it asked us to evaluate it, then we would write our answer as 25. We just need to make sure we follow the directions. So we're going to leave that as 5 to the 2nd power. Now this is the 3rd day in a row that I'm going to make this statement, and that is, yes, I realize some of you will see a shortcut. I will not be discussing shortcuts with regards to exponents for a while. If you figure it out, utilize it, okay? All right. So that simplifies to 5 to the 2nd. All right, go ahead and do 1 through 5. All right, so we'll need to talk about a couple of things here. Let me just show you a very common mistake with problems like number 1, 2, and 4. A very common mistake when we haven't done things like this in a while is we try and do something like this. You can't do that because you actually have 11 10s on top and 8 10s on the bottom, not just 1 10. So you can't do something like that. So make sure you don't make that common mistake. And so I saw some of you write out 10 11s on top and 8 10s on the bottom, and you went about this the same way that I went about in the example, and that's fine. But you also need to kind of think about what's happening. Visualize it. If you had 11 10s on top and 8 on the bottom, all 8 of them on the bottom are canceling out, leaving you with 3 10s on top. That's another way of thinking about it. So that should simplify in exponential form to 10 to the 3rd. And then, obviously, number 2 is 7 to the 2nd, and 3 is x to the 8th, and number 4 is negative 3 in parentheses to the 5th. But then that brings us to number 5. I saw some of you, you wrote it as n to the negative 8 power. I understand how you got that because you've already kind of figured out the trick when you're dividing things with exponents. But in mathematics, we tend to not leave things with negative exponents. So that would not be correct. Anybody have any idea what it should be?
1 over n to the 8th.
It should be really 1 over n to the 8th. And the reason is because you have 4 n's on top and 12 n's on bottom. All 4 n's on top are canceled out if you want to think of it that way. But remember, you're canceling them out and replacing them with a 1. And so you end up with a 1 on top and 8 n's left on the bottom. Any questions about number 5? That's the way that we should be writing that. Okay? So now, what if we take the idea that we just saw in number 3 and number 5 and we add some coefficients? Well, there are several ways of thinking about this. One way is thinking about it in terms of the prime factorization. So in other words, if I do the prime factorization for 14, that's 2 times 7, and then 3 x's that I'm multiplying together. And the prime factorization for 35 is 5 times 7, and then 2 x's on the bottom. I mean, when you're reducing fractions, that's what is really happening. And so now we attack this the same way we attacked that very first problem. 7 goes into 7 once and once. X goes into x once and once. And same thing right there. And so you're left with 2x on top and 5 on the bottom. But here's how most of you would probably try this problem. Most of you would probably do it this way. Instead of writing out the prime factorization, you would probably say, well, I can see that 7 goes into 14 twice and 35 5 times, just like you would reduce a regular fraction. And that's fine. And then, when you look at this piece right here, you're looking at it in terms of the way we dealt with the first 5 problems, right? Or you could think of it the way that we have over here. Okay? But regardless of how you deal with that, you're going to end up with 2x over 5. Okay? I'd like all of you to try number 7. So I'm going to deal with number 7 the same way that I dealt with number 6. I'll do it both ways. And that's kind of how I talked about that other one. I'm going to deal with it in terms of the prime factorization so that I can then just cancel out factors or common factors. And that idea will come back again later in the year. But once I deal with that, I end up with negative 5ac on top and 2b on the bottom. Many of you, I know, dealt with the negative 25 over 10 like this. You saw that 5 went into the top and 5 went into the bottom. And then you dealt with the letters, kind of thinking of it like that. But regardless, you should get negative 5ac over 2b. Are there any questions about number 7? Are we good? Okay, right now I want you to go ahead and do the rest of that block of problems, 8 through 15, and I want you to work on them with your shoulder partner. 8 through 15. All right, so once again, so we can kind of write it out using prime factorization, listing all the variables out, but at some point we have to kind of visualize what's happening. So we need to simplify or reduce the 10 over 15, which simplifies to 2 over 3, and then we have 4 m's on top and 1 on the bottom. That 1 on the bottom is going to cancel out and leave 3 left on top. And so we should end up with, and I went ahead and did this one the long way, but we should end up with 2m squared over 3. B over ABC, we have a b in common on top and bottom, so we will basically cancel those out and replace them with 1s. Don't forget to do that. And it makes it clear then we have 1 over AC. Number 10. If we visualize the w's, all the w's on top are going to cancel out and leave me with 6 w's on the bottom. With regards to the x's, all the x's on the bottom are going to cancel out and leave me with 6 x's on top. So we should end up with x to the 6th over w to the 6th. Number 11, we would want to simplify the 24 over 72, which simplifies to 1/3. And as far as the c's go, all 5 c's on top will cancel out and leave us with 10 c's on the bottom, so therefore it should be 1 over 3c to the 10th. Number 12, the negative 32 over 8 simplifies to negative 4 over 1. As far as the x's go, we have 1 more x on top than on bottom. And as far as the y's go, we have 2 more y's on the bottom than on top, so therefore they will remain on the bottom, so we end up with negative 4x over y squared. Number 13. Same idea. Go through, simplify the 20 over the 24. We have 4 more a's on the bottom, 3 more b's on top, 11 more c's on top, and 2 more d's on the bottom. So therefore it should be 5b cubed c to the 11th over 6, a to the 4th, d to the 2nd. And then number 14, simplify the 15 over 75. We have 3 more a's on the bottom and then 6 more b's on the bottom. That should be 1 over 5a cubed b b to the 6th. So any questions through number 14? All right, so now we're going to take what we just learned with something that we talked about yesterday. So yesterday we talked about this idea of a power of a quotient property, where we take something like this and we think of it as 3x quantity of that squared over 5 squared, and then simplify numerator and denominator, and we simplify like that. We end up with 9x squared over 25. But what if you have something like this? Okay, this looks very similar to a problem that we did yesterday. I just added a few more pieces to it. If I don't say anything, most of you go into automatic pilot and you go straight to the power of a quotient property. But what should we probably do first? What's that? Well, we're not solving. Simplify it, right? And really all you're doing then is you're following the order of operations. Because when you follow the order of operations, what's the first thing that you're supposed to always do? Deal with whatever in parentheses. Simplify within parentheses. So all we're doing is we are doing that. We're following the order of operations. And so we took a look at, I don't know how many problems we just did, 15 problems like what's inside the parentheses. So when we simplify what's within the parentheses, that simplifies to b cubed over 2a squared, right? Because 7 over 14, that simplifies to 1/2. We have both of these a's cancel out, and we have 2 more on the bottom than on top. That b right there on the bottom cancels out, and we have 3 more on top. So that's the reason why we end up with b cubed over 2a squared. Now we deal with this in terms of what we talked about yesterday. So we can think of that as b cubed cubed over 2a squared cubed. And so the long way of getting there means we have 3 groups of b cubes on top, and on the bottom 3 groups of 2's and 3 groups of a squareds. And then we simplify that, and I know most of you can jump straight to the answer from there, and that's fine, but just be careful. We end up with b to the 9th over 8a to the 6th. So any questions with part A of number 15? All right, you go ahead now and do part B. Part B, we have negative 24x cubed y squared over 3x to the 6th. Follow the order of operations. Simplify within the parentheses first. When we do that, we end up with negative 8y squared over x cubed. And now we can utilize the power of a quotient property. And think of it this way. And we should end up with negative 32,768 y to the 10th over x to the 15th. Some of you had fun with that. If I were doing this, I would have taken 2 8s, 64, another 2 8s, 64, multiplied those together, and then multiplied by 8. It probably would have been a little bit faster than going 8 times 8, then take that, multiply by 8, then multiply by 8 again. That's what some of you were doing, and I think it took you a little longer than it needed to. And then part C, simplify within the parentheses, following the order of operations, gives us this. Then we utilize the power of a quotient property. Think of it this way, extending the product, and we end up with n to the 8th over 625a to the 4th. Any questions? All right, we are finished for today.